So this is going to be a pretty long video, but you can skip to any part that pertains to you or you need help with. All right, so but I'm going to review some of the items that might be difficult for you to process to get ready for the test for tomorrow. Okay, so I'm going to ignore number 1 because it's not hard, but I want to get you started with number 2. I am not going to show all of the problems, all of the steps, but I'll get you started. Okay, so because a lot of people missed this during the test today, the quiz today. This 8 and 32, there is no way to write 8 to power something to get 32. It's not possible. So what you need to do is to find a number that can be used. So 8 is like, we can do 8. We can do 2 to power 3 to get 8. We can also do 2 to power 5 to get 32. That's what you are trying to do, okay? So let's try to do here. So we're going to replace this 8 by 2 to the power of 3. And then copy whatever is on the original exponent. And the 32, we're going to call it 2 to the power of 5. Okay. Now what's left for us to get one exponent for this. This needs to be made one exponent. Right. We're going to use the property of exponent that says that if you have something like this, an exponent, a power with an exponent, you multiply. A power with exponent, you multiply this. Okay, let's multiply. So don't forget to do 3 times x, that's 3x, and then 3 times -5, that's -15, and then you have 5 over here. So what is left now is to solve this simple linear equation. So I'm going to add 15 to both sides, and I will get 3x equals 20. This is going to go away. Then I can divide both sides by 3. So x equals 20 over 3. That is that. Okay, I'm going to skip over a few and go to the part that might be a problem for many of you, which an example would be like number 5. Okay, so this 2 cannot be multiplied with that 2. These 2 cannot be multiplied together because we have to follow order of operation. We cannot multiply these 2 because PEMDAS says that we should do exponent before multiplication. Since there's a variable in the exponent, we don't know, we can't do the operation, so we leave it alone. We do not multiply those 2 things. Okay, so now what is left is to divide both sides by 2. So divide both sides by 2. This is what you do when you divide both sides by 2. Divide by 2. But we need a 1 there. So just a little sidetrack. If I want to divide 4 by 2, I simply put the 2 below it, okay, or underneath it. So this is 4 divided by 2. Or I can say 4 divided by 2 is really 4 times 1 over 2. Because if I put 1 over here, I do 4 times 1 is 4, and 1 times 2 is 2. So another way which is the same thing as that. Another way to think about division is if I divide by 2, if I'm dividing by 2, I'm simply multiplying by 1/2, 1 over 2. All right, so now the right side will become 1 times 1 is 1, and then 32 times 2 is 64, and then this is gone. So we have 2 to the power of x minus 3, and now this is going to be 2 to the power of x minus 3, 2 to the power of 6. Now this is a fraction, so we need to have -6 because it's a fraction. So whenever you have a fraction, you need to have like a negative exponent. And so we have the same base. This is a base of 2. That base here is 2. The same base is 2. Then we're ready to make the exponent equal to each other. So it will look like this, like x minus 3 equals negative 6, and add 3 to both sides will give you x equals negative 3. That is the answer to that. Okay, similarly, look over here on the number 6 right here. I want to get rid of this 1/5. The opposite of that is to multiply by 5. Multiply by 5. Multiply by 5. This time we are multiplying. We are not dividing. Unlike this one that we are dividing, this one we are multiplying. So we can put 1 over here and do 1 times 5 is 5. And then 25 times 1 is 25. And then simplify this as 1 over 5. If you divide out 5 there and 5 there is 5. Okay, it's 1. So 1/5. So this, the left side, if 5/5 is going to go away as 1. And then you're going to have 5x plus 1 equals 1/5. Now you can write the right side as 5 to the power of negative 1. And then this one is 5 to the power of x plus 1. I'm going to leave you to finish that on your own and see if you can set the exponent equal to each other and then solve the equation. All right, that's going to be yours to complete so that I don't do all the work for you. The next problem is going to be something similar to, it's just basically finding logs. So this is pretty easy. I'm going to go to one that might challenge you. The one that was missed the most was those ones with fractions like this. All right, so let's say I'm going to find this. Well, I'm going to say this answer, let it be x. I don't know where it is. So I'm going to do 1 over 16 to the power of x equals 8. Okay. I just let the answer be x, okay, and then I say, okay, I can write this exponential form now. And then I'm going to replace this 116 with a base that is common to 16 and 8. That will be a 2 to the power of negative 4 raised to the power of x, 2 to the power of 3. And now I can get 2 to the power of negative 4x equals 2 to the power of 3. And now you can set the exponent equal to each other. These exponents are equal to each other because the base is the same. And then you can solve for x. And your x is just going to be s equals 3 over negative 4, negative 3/4. All right, there is another one that might give you trouble. Both of them are fractions, okay? It's not too hard. Let the answer be x. So 1/3 to the power of x equals 1 over 81. So then write this as 3 to the power of negative 1 to the power of x is 3 to the power of negative 4 because 3 to the power of 4 is 81. So whenever you have a 1, you turn it to negative exponent. And now we can multiply the exponent as 3 times this one is negative x. And then this one is 3 to the power of negative 4. And then you can set the exponent equal to each other and finish from there. All right. Now we get to a little bit challenging one like these ones. Yeah, let's go to number 15. Well, I'm going to do the odd numbers on this left side for you to see the ones that are more challenging. I'll do all the odd numbers for you, okay? Here is 125. I know it has to be 5 to the power of 3. So it's 5 to the power of 3 to the power of negative 3r plus 1. Now 625 is really 5 to the power of 4 to the power of r. Now I'm going to distribute this. I'm going to distribute this 3 to all this, okay? So it will look like this. It will be 5. 3 times negative 3 is negative 9 r. 3 times 1 is 3. And then 4 times r is 4r. And now I have the same base. I need to set the exponent equal to each other. Like so. Negative 9r plus 3 equals 4r. Well, I can take this negative 4r to the other side, like that. And then take the 3 to the other side. And now this is going to cancel. And then I will have negative 13r equals, it's going to cancel negative 3. So r is negative 3 over, divide both sides by negative 13. R equals negative 3 over negative 13, which they are going to cancel the opposite the signs. So r equals 3 over 13. Okay. Look at number 15 right here. I need to set this 1/4 as a base of 2. Well, I could, or I could just do base of 4, because 64 can be written like a base of 4. So we can have 4 to the power of negative 1 all to the power of negative n minus 2, and then 4 to the power of 3 to the power of 3n. And now be careful to distribute this negative 1 to each of them. Be careful about that, okay? So 4 to the power of n, because negative 1 times n is n. And then negative 1 times 2 is plus 2. And then this is going to be 9n at the exponent. 9n. We're almost done. We have the same base. The same base, set the exponent equal to each other. And now we can do this and do n plus 2 equals 9 n. And then we can subtract 9n from both sides. Subtract 2 from both sides. And then this is going to be negative 8n. This is going to go away. And this is going to go away, equals negative 2. And now we can divide both sides by negative 8. So that n equals 2 over 8, which is 1 over 4. N equals 1 over 4. Okay, I'll do one last one that looks complicated, okay? But it's not quite complicated. I don't know which one to do. I think I might do number 18 instead. This one has variable on both sides. No, I'll do this one. All right. So we can do, rewrite it 127 as 3 to the power of negative 3, negative 3n. 243 is really 3 to the power of 5, because 3 to the power of 4 is 81. And then you do one more times by 3, you will get 243. So it's 3 to the power of 5. So times 3 to the power of 5. Everything to the power of 2 minus 3n. And then 9 is 3 to the power of 2. Now, you need to multiply the exponent together, okay, like those. So 3 to the power of 9n. And then you distribute this 5 to those two terms. So it will be 3 to the power of 10. And then 5 times negative 3 is negative 15n. That's negative 15n. And then 3 to the power of 2. Now we must not set this exponent equal to each other straight away. We cannot do that yet. We cannot set this exponent equal to each other like that. That's not going to be correct. What we need to do instead is to use the rule to get only one base of 3 over here. Only one base of 3, another base of 3. We need only one base, just one, not two. These are two bases. So I need to find an exponent that will work with this. You're going to remember the rule that says if I have x to the power of a, x to the power of b, what do I do with the a and b? Yeah, you got it right. We add them together. So we're going to add them together. We're going to add 9n plus 10 minus 15n. Okay, we combine like terms. 9, 16, and negative 15 is negative 6n. And then 10. That is what's going to be at this exponent. Okay? All right. Now we got this one base. Now we're going to set the exponent equal to each other. Now we're ready to do that. So we're going to do negative 6n plus 10 equals 2. Subtract 10 from both sides. Negative 6n equals a negative 8. Divide by negative 6. That will be 3 over 4. Oh, 4 over 3. I'm sorry, 4 over 3. That is what the value is, okay? All right. That's all for exponent. You can try the rest on your own because you're going to have to earn some credit for yourself by doing them. I just want to review some of this writing in logarithmic form. All right. If you look at this, look at number 22. Well, I want to write this in log form, okay? The only thing you need to remember is that it's going to have log, okay? And then this 16 is the base. This 16 is the base. That 16 must be used as a base of the log as well, okay? Now, remember when we did the, when we're writing exponential form, this 2 here has to be the answer at the end that we're looking for. What power? This is the what power that we're looking for, these 2 over here. So that will be what power. All right, that will be our equal sign. What power? Power is negative 2, right? What power? Power is negative 2. Then the number that needs to find, we need to find the power is 1 over 256. So we kind of deconstructed this from exponential form to log form by considering that the base have to be the base. The power is the power we're looking for. What power? That's the power. And this number here does not really matter. That's just a number, okay? All right, here is another one. Here's another one. Okay, the base. Well, I think I'll do one more that has I'll skip now to number 29. Number 29. All right, here you have we're going to write log form for this, so it's going to be log. Again, the u is the base, so we need u for the base. That's the base. What power? What power? That's the answer we're looking for. The power is k, and the number is v. That's it. They match. Base with the base. What power is the power? And then v is the number that we're looking for. All right, I'm going to do one more of that. So that will be this one, number 31. So you have log. All right. The base is 17. That's the base. What power is negative 9? What power? And x is the number. All right. So now I go back to the top over here to answer your question about, no, actually to make a correction to the homework. After number 22, there was in the worksheet that you have, this direction is omitted. You need to write it on your paper. I will check tomorrow that you have it written. This direction must be written. Like write in exponential form. The question from number 23, 24, 25, 26, they're all asking you to write this log in exponential form. So let's try to write the first one exponential form, okay? Right, here is the log, okay? I need what power? What power is the log, okay? So what power? Here is the base. I need the base first, okay? The base. The base is C. Now, what power? The power is A. That's the A right there. That's the answer. And then equals B. So the base must match the base. Let's kind of zoom a little bit. The base is the base. And what power? This is the what power. That's the power. That's the power. That's the log answer, okay? That's the answer is the power. What power? The answer is the power. And then B over here is the number, okay? In all the worksheet I made for you today, this parenthesis is missing. So you can go ahead and put parentheses for the number itself. My computer could not make that. So you need to put those parentheses so you don't get confused. Okay, those are the parentheses over there. You can do the rest, okay, by putting parentheses. That's a number. All right, let's do one more for this. Let's do number 25. All right, the base. What's the base? You can look at it for yourself. The base is 1/3. Okay, you start with the base, 1/3. Now I told you if it's a fraction, then you need a parenthesis. Now, log means what power? That's a power. What power? Okay, we're gonna put that what power over here, and then the number is y. This is pretty easy if you're interpreting it correctly. Now we go backwards again. I think I've kind of gone through everything except for some of these log that are weird. Look at number 37. So what is the answer to this? That's what it's asking. What is the answer? Well, I can think this way and say 1 to the power of x equals 49. Is there any way I can do 1 times 1 times 1 times 1 to some number to get 49? No, this is undefined because 1 is not allowed to be at the base. All right, the same way, this is undefined because negative number is not allowed to be at the base unless if you raise the negative number to the exact number of times to get 125. But it's not going to work because we need a negative. When you do negative 5 to 3, it should be negative 125. So this one is undefined as well. All right. We cannot use 0 according to our lesson in the class. This number 40 is undefined. Also, we can't take a log of a negative number. See what I'm saying? What power with 32 will give me negative 1/2? Well, the base is already a negative. It's not going to be matching this base, which is like 2 to the power of 5 and then x. So the base are not going to ever match. So the negative doesn't work with logarithm. This is undefined. Well, I hope this video helps you. You need to go back online now. Go to Google Classroom. I have all the answers for number 1 to 40. And tomorrow, you'll be responsible to show me that you know 20 of this problem. Play the video over and over again. You can text me if you need any question. If you have any question, I hope that you do well in tomorrow's test.